All right, y'all. So we're gonna try the other way now and go from slope intercept to standard. So we're gonna go from something that looks like this to something that looks like ax squared plus bx plus c. So if you'll notice, standard form has x's and y's all on one side and a regular number on the other side. They're all integers, meaning like no decimals, no fractions, that sort of thing. So let's move this around, see that it turns into this, and then you'll try it with this one. So we got to put all the x's on one side. This is negative 2/3 x, so we have to add, sorry, negative 3/2. So we have to add 3/2 x and add 3/2 x to both sides. They cancel out over here, and on the left side you're left with y plus 3/2 x and equals just 3 on the other side, which is just a positive 3. That's great. It kind of looks like this, except that ridiculous fraction. To get rid of it, if you take the whole thing and multiply by 2, you multiply this by 2, you multiply this by 2, you multiply this by 2. We're doing the same thing to both sides, so we're not changing anything. We're basically, I mean, I know you see it twice, but basically you're multiplying this side by 2 and multiplying this side by 2. This gets distributed in twice, so you get 2y, let's do it in black. You get 2y plus 3/2 times x times 2. 3 divided by 2 times 2, these cancel out, right? Think about 3/2 times 2 over 1, right? Times 2, you get 6 over 2, you get 3, which is this part, because these have canceled out. I'm assuming you know how to work with fractions. If you don't, not a problem, but you're going to need to, so come see me. So that's great, and then, let's see. So this, when this multiplies in, you get 2y. When you multiply 2 times 3/2 x, you get 3x. And on this side you get 3 times 2, you get 6. And now, since x's and y's are both on the same side, integers, we're set. Try that with this one. Pause me and go. Alrighty, so we're going to play the same game with this thing. And so let's take all of this and drag it over here. I know I want the x's on one side of the equation, so let's get rid of 2/3 x by adding 2/3 x to both sides, plus 2/3 x. So on the left side you're left with y plus 2/3 x plus 2/3 x, and on the right side these have canceled out, so you're just left with positive 4. Great. I don't like that fraction, so let's multiply everything by that denominator, this denominator 3. But you got to do it to both sides, right? We have 3 of these and 3 of these, so this sort of distributes in, and you're left with 3 y's, right? Because it's like 3 times everything in the packet, so you get 3 y's, and 3 over 1 times 2/3 times x. Well, you could think about it as 3 over 1 times 2/3 times x over 1. Right, that's this times this. If you multiply everything on top, you get 3 times 2, you get 6x over 3, and these cancel out, and you're left with 2x, right? You can do that earlier and just simplify by slashing those, and you're left with 2x, right? So 3 times 2x over 3, these 3's cancel, and you're just left with the 2x. And on the other side, you're left with 12. Cool. They're not multiples of each other, so we're good to go. Bing! Great. I think that's what we got here. Let's try it. There it is. All right. Last 2 tricks. On your notes, you put in these, or I'd like you to put in the coordinate names for these, and hopefully we'll hide them for you for a second, like that. If you need to pause me and go back, that's fine. But I'd like you to tell me what the coordinate names for all of these are. Like this one is over 3 and up 2, so it's 3, 2. So go through, write all those numbers out, and take a look at all of the values. Yeah, pause me until then. Go. Okay, so if you noticed as you wrote all these out that this is 3 over 3 up 2, over 3 up 1, over 3 up 0. All of these have the same x value, right? And the y value doesn't get to play in the equation. So this line is vertical, yeah? And what you'll notice is that in all vertical lines, the x value is equal to the same number. And so this is the equation for this vertical line, yeah? So what's the equation for this vertical line? If I could hit it straight, right? This point is over 1 up 1. This point is over 1 up 2. This point is over 1 up 3. What's the equation for the line? Oh, hey, look, all my x values are the same. So x is equal to 1. Cool? So all of the x coordinates in a vertical line are the same. So the equation is x equals that number. Great. Likewise, oh, well, you try that out here. What's the equation? Well, all of these are -4 comma something, -4 comma 1, -4 comma -1, -4 comma a million. The x values are all the same, so x is -4 is the equation for the line. Cool. Take that same idea and try it here. Find the names of the coordinates for all these points, and then think about what they all have in common. Pause me and go. All right, so if you listed those out, they look like this. This is over -2 and down 2, over -1 and down 2, over 0, down 2, right? Over 1, down 2, All the x values are different, but look, all of these y values are the same. Right? Here, the y value, the y value, the y value, all these y values are at -2. And so all of the y coordinates have the same. So the equation is y equals that number. So this line is y equals -2. On your example, which you should pause me and try, the equation for this line, the equation for this line is, well, this is 3 comma 2. And this is -3 comma 2, and this is 0 comma 2, right? This is the x, this is the y, this is the x, this is the y, this is the x, this is the y. All the y values have the same value. It's y equals 2, and that's the equation of that line. Sweet. That's the ball game. We'll try it out when you get back here, and we'll see you then. Bye.